This is the video where we introduce the concept of predictive analytics using a real example. You'll learn what predictive analytics is, why predictive analytics is useful, and why model interpretation is important for us actuaries. Let's begin by thinking of a real example, a FICO credit score. Every actuary is familiar with a credit score. This is a way that companies assess if an individual is trustworthy. Companies will only make a loan to a person if they believe that that person can pay back the loan in the future. So on your own, go through the FICO credit score questions. Try to answer them two different ways. First, go through and apply your actual answers and see how well it matches your real credit score. Next, go through and either try to get as high of a credit score as possible or get as low of a credit score as possible. And when you come through each question, try to think if that's improving or lowering your credit score. So first I'll go through and answer these as an average person might. How many credit cards do you have between 2 to 4? How long ago did you get your first credit card? It was 2 to 4 years ago. How long ago did you get your first loan? Auto loan, mortgage loan, or student loan? Well, that would have been about 5 to 10 years ago. I got my first student loan when I was beginning university. How many loans or credit cards have you applied to in the last year? I have applied to 2 credit cards in the last year. How recently have you opened a new loan or credit card? Let's say that I recently wanted to travel, and so I opened a new travel credit card, and that was between 3 and 6 months ago. How many of your loans and credit cards currently have a balance? Let's say that I'm behind on one credit card. I'm fairly diligent in paying off my balance. Besides any mortgage loans, what are your total balances on all other loans and credit cards combined? So let's say that I have student loan balances that are about between 10 to 20,000. When did you last miss a loan or credit card payment? Let's say I'm very, very diligent and I last missed a payment 1 to 2 years ago. What was your most delinquent you have ever been on a loan or credit card payment? I don't know, 60 days. Okay, we're almost done. 8 out of 9 questions here. How many of the loans or credit cards are currently past due? Let's say that I have one that's past due. And what are your total balances on all currently past due accounts? Let's say between $250 to $499. Okay, last question. What % of your total credit card limits do your credit card balances represent? Let's say that I have a small balance and I have a large credit limit. So this is between 20 to 29%. Finally, in the last 10 years, have you ever experienced bankruptcy, repossession, or account in collections? No. Your credit score is estimated between 655 to 705. Okay. How can I understand that? Well, your credit bureau will give you some rankings. They'll say 800 to 850 is exceptional. 740 to 799 is good. In this case, I am in the good range. So how do they come up with this credit score? Well, that's a great question. Recall that the goal is to try to predict whether or not you will be financially reliable. If you have a high credit score, it means that it's very unlikely that you would default on a loan. And if you have a low credit score, it means that you are quite likely to default. So we can actually take these questions and build a model. The model is going to predict whether or not the person will default. So here are the questions. Question 1 was, how many credit cards do you have? This would be, in modeling language, a variable or a predictor. And it would take on numeric values that would be like integers, such as 0, 1, 2, or 3. How long ago did you get your first credit card? This would be called length of credit, and so forth. So we'd have a variable for each of these questions, right? And then we know that there's a certain importance. Each of these questions is going to be either improving my credit score or lowering my credit score. If it's improving the credit score, I would associate that with a positive value. I should be adding something. Conversely, if it's bad for my credit, if it's making me risky, for instance, the total balances that are on all currently past due accounts, I know that that should be negative, because if I have a huge outstanding balance, then that should lower my credit score, right? And so this should be a negative sign. And this should also be a fairly large number. See, this is negative 0.1, because I know that this is going to be a very important factor in determining if I default on a loan. And then I go through and I answer the questions. By doing this, I just fill in my values. So let's say I had 5 credit cards. I would put in a value of 5. My length of credit was 4 years, and so forth. And then I'm not really sure what I'm doing at this point, but let's just say that I took the product of those two, so that I know that there's a certain inherent importance in each of the questions, but that also depends on my value. The number of credit cards is important, but it's also important how many you have. So I take the product of all of these, and I'm not really sure what else I'm going to do, so I'll just add them all together. And I get some number, negative 3.625. Well, this doesn't look like much of a credit score at all. It's just a number. Well, without explaining what I'm doing, without explaining too much what I'm doing, I'm just going to take the exponent of this number and then divide by 1 plus the exponent of that number. And that will translate it into a percentage between 0 and 1. In this case, it's 2.6%. I'll call this the probability of default. And then I can take 1 minus that number, multiply by 1,000, and I get 974, which is an excellent credit score. If you have a credit score of 974, you probably don't need to be watching this video. So in other words, you can think of a credit score as a probability. Like, let's say your credit score was 750. Divide that number by 1,000, and that would be the probability of default. That would be the probability of not having a default. And then the probability of default, of not default. Let me rephrase that again. Probability of not default would be 75%. The probability of default would be the complement of that, would be 1 minus 0.75. Now this is clearly somewhat of a simplification. However, it illustrates an important point, which is that actuaries use real data in order to predict future financial outcomes. So, in summary, predictive analytics is a set of tools that use data analytics and machine learning to solve business problems. In this case, you saw how you could use a person's financial history to predict whether or not they'll default on a loan in the future. Now, we used some math that we didn't fully explain, but when we get to the chapters on machine learning and specifically generalized linear models, you'll see that this spreadsheet was really just a type of GLM. We also saw that modeling is useful because it lets us predict the future. We had all of the historical information already. An accountant could have looked at that statement. They could have told you if the transactions were accurate or not. They could have calculated balance or other historical info. But only actuaries can look ahead into the future and make predictions. Finally, we saw that model interpretation is important for actuaries because of the financial liability involved. If my credit score suddenly decreases, I can look on my credit report and get a reason. They'll usually say my length of credit was not long enough, or I missed a payment recently. Suppose that you're an actuary predicting someone's acceptability for life insurance. If that person gets denied life insurance, they will be very upset and they'll want to know why. So anytime that there's a large financial liability involved, it's critical to be able to explain your results.